Then for ground motion selection, we can see here the screen where we have the basic mode search and the advanced mode search. And this depends heavily on the type of database that we choose. So for example, if we're choosing the Ithaca database, we have this basic mode search parameters. So we can decide the minimum magnitude, the maximum magnitude. And the same for distance, full type. We have a drop down menu with different types from normal, reverse, track sleep, thirst, unknown, or any of them. BS30, PGA, and latitude and longitude. Again, if we don't know this latitude and longitude, we can select it from the map, and we can also see that we have a boundary because the Ithaca database is analyzing and processing only the Italian region. We can also decide to customize our radius because as of now we will search only in this red area, but we can increase the radius so that the area of search, the region of interest, is bigger, and we will retrieve, obviously, in this case, more ground motion. So, for example, we can set it to 200 kilometers and select it. After this, we can select the maximum number of results that we want to see, and this will be showed in order as they are in the database. So if we click search, we will see these ground motions to show here in the record list. We see also the columns. These are all the basic mode parameters, but also all the other ones that are present in the Ithaca database. As you can see, they are a lot, and all these ones that usually are not necessary to do any search, but still they are available in the advanced mode. So if you want, if you need them, you can search based on these advanced mode parameters. Once we see this, for example, if we have a very large number of results, let's for example exclude this, meaning that this will retrieve every possible ground motion in the database that is respecting these rules. If we click search, we will have a higher number. As you can see bottom right here, we have 289 records divided into 3 pages of 100 records each, but they are a lot, so maybe you want to see them, to look at them in a specific order, so you can click, for example, in the column of interest, and with the first click you will sort in descending order from the biggest to the lowest, and if you click again you will sort in ascending order, and you can do this for any column that you want. So this is for the Ithaca database, but the same thing applies to all other databases. You can do basically the same thing. Then an important thing is that you can also plot them, clicking the plot button. This will be this dialog will be will appear, and you can see all the components of these ground motions. You can see the two horizontal components H and E, H and N, and also the vertical component H and Z. You can do this for every record, and you can also select them, and selecting them allow you to either download them, clicking download selected. You can choose the destination folder, and this will download a single folder with all these ground motions, and selecting them allow you also to look at them in the map. We have this map view where you can see that these 4 records selected here are effectively in this region. So 1 is here and 3 are in this cluster here. So this is what this panel allows you to do. And we have also to mention that this modality of data retrieving was online mode. So we are basically, as you can look at here and read here, are fetching data from the API online of these 4 databases. If you don't have connection, you will fall back automatically, and you can also switch manually to offline mode. We have also an offline database that allows you to do your work without connection, even if on a limited number of elements, because if we see here, for example, ESMD, we exclude all, meaning that we will retrieve all the database from online data. We see here above 17,000 records. This is online. When we go offline, we will see a lower number because we have just a part of it offline, and this is 6,000. So this is a important distinction. After this, we have, performed our search in terms of ground, let's say, waveform matching, as you can see, because we are selecting all these seismological parameters, and based on these parameters, we are effectively doing this search. So this is called a waveform matching or waveform search. Let's say that we are interested in, I don't know, 30 maybe waveforms. Okay, these are the first 30. Then we want more, specific search on these 30 ground motions that is called spectrum matching. This basically is performing um, compatibility search on the spectrum regarding all the spectrums of these ground motions and comparing it to the target spectrum that we computed in this panel. So when you compute the target spectrum in this panel, it will be automatically imported in the ground motion selection spectrum matching tab. So you can look at it in this mini plot here, and you can perform this search on compatibility based on the spectrum. So spectrum compatibility. You can also choose if you want a single period, meaning the compatibility of the spectrum just on this single point. This is the period one. So only in this point with period one you will do the search, but you can also decide to do the search on an extensive, period range, and you can here insert the ranges, for example, from 0.5 to 1.5 or more than one. So you can also add another period, for example, from 2.0 to 2.5, and you have to insert them in this format here highlighted in the input box. But let's say that now we want a single period. An important thing is that you have to also insert the matching tolerance, because maybe there will not be present any ground motion that have a spectrum exactly with the same value in this point of the equal to the target spectrum value. So you may probably want to search for something that is near the value of the target spectrum with a tolerance, meaning a displacement of this percentage. Now is the 30 percentage, and you will after see here a filtering of these ground motions, and you will see only the ground motions that have a spectrum that in this point 1 second have an error with respect to the target spectrum in the same point within this tolerance 30%. So we can run it clicking search. This will be a bit slow just because it has to retrieve every spectrum and compare it, but it's not so slow for a limited number of records. And in this case, since it was a design spectrum, it was not a real spectrum, so we don't have any ground motion that is matching this period spectrum of the target within this tolerance of 30%. Then, when you selected your final set of ground motions, let's say 15 ground motions, after having performed the waveform matching and the spectrum matching, you have this set of ground motions, and you can again select them. And after selecting them, you can click on this upper left button on toolbar actions. And after clicking here, you will see a bunch of actions that can be performed on these selected ground motions. You can go to spectral processing to process the signal, go to spectral scaling to scale it, go to RSP match to match its spectrum with respect to a target spectrum that we computed previously in the target spectrum panel. You can go on ArtiveQuake panel, where you will generate an artificial accelerogram, or you can go to site response analysis to perform this processing on the ground motions. The only constraint present is that you can go to RSP match, ArtiveQuake and site response analysis only if you selected just one ground motion, while for signal processing and spectral scaling you can select more than one ground motion at the same time.